Hello everyone, welcome to my YouTube channel Java by MK. So we will continue with the previous video, top 50 problems on microservices. These are just theoretical questions. Having knowledge of these theoretical questions gives a plus point when you will start implementing these concepts. So, so there are going to be lots of new questions even for me. So we'll work together to complete this. So till 15 we have completed, starting with 16. What is sidecar pattern? So before I continue, I will just tell this that I'm using ChatGPT, where I have the list of 50 problems that I'm going to discuss. So back to the problem. What is sidecar pattern? The sidecar pattern involves deploying helper service alongside a main service to manage tasks like logging, monitoring, and configuration. So this is sidecar pattern. Okay, so we have a helper service along with a main service to manage tasks like logging, monitoring, and configuration. We know for logging we use Zipkin. Okay, for tracing we use Zipkin like this Sleuth. For monitoring we have another service. For configuration we already discussed that we use Spring Cloud config server. We have circuit breaker also, like Histrisk, where we manage the fallback of the any of the services. And how do we ensure that there is no fallout and resource loss? Okay, so how do you ensure data consistency in microservices? Using techniques like eventual consistency, two-phase commit, and the saga pattern. What is saga pattern? This is even new for me. The saga pattern is a design pattern that provides transaction management using a sequence of local transactions. Okay, so I will explain saga pattern with one example. Suppose I have four services: order service, payment service, inventory service, and shipping service. So what how saga pattern will work, I will explain. Suppose we order service creates a new order and publishes an order created event. Payment service listens for the order created event, processes the payment, and publishes a payment completed event. If payment fails, it publishes a payment failed event. Inventory service listens for the payment completed event and update the inventory and publishes an inventory updated event. If the inventory update fails, it publishes an inventory update failed event. Shipping service listens for the inventory updated event and ships the order. So in case of failure, if the payment service publishes an event payment failed event, the order services listens for this event and cancels the order, like this. So what I'm trying to say, so we can see that we have when we have four different services and all are interdependent. So suppose if third service failed, we need to have a mechanism where we can revert all the changes made by the first and second and the first services. To accomplish that, we use saga pattern. So moving to next problem, how do you implement security in microservices? Yes, for saga pattern I will make a separate video. How do you implement security in microservices? Security can be implemented using OAuth 2, JWT, and Spring Security. So JWT and Spring Security, we all and OAuth 2 is all three are different ways to secure the application in a different way. Authorization and authentication both are covered in these three different services. So what is bounded context in microservices? A bounded context is a concept from domain driven design that defines the boundaries within which a particular domain model is valid. What is Netflix Eureka? Netflix Eureka is a service registry for resilient mid-tier load balancing and failover. Okay, so what is this Netflix Eureka? Is a service registry for resilient, and like Netflix Eureka could be Eureka client or Eureka server. We will understand what Eureka server is, what Eureka client is. Okay, what is a Spring Cloud Netflix? Spring Cloud Netflix provide Netflix OSS integration for Spring Boot application to implement service discovery, circuit breaker, and uh, in intelligent routing. How do we handle logging in microservices? Using centralized logging systems like ELK stack or Splunk. What is the role of Kafka in its microservices? Kafka is used for building real-time data pipelines and streaming applications, providing a high throughput, low latency platform for handling real-time data feeds. How do you handle versioning of microservices? Versioning can be handled through URI versioning, header versioning, or context negotiation. What is Histrisk? Histrisk is I already discussed, is a latency and fault tolerance library designed to isolate points of access to remote system services and third-party libraries, stopping cascading failure, enabling resilience in complex distributed systems. What is Ribbon? Ribbon is a client-side load balancer that gives you a lot of control over the behavior of HTTP and TCP clients. I will cover in different tutorial all these topics, but as of now, let's focus on the definition and theoretical part. What is FAIN? FAIN is a declarative web service client. It makes writing web services client easier by reducing the complexity of REST client implementation. What is the difference between synchronous and asynchronous? Synchronous communication requires both the sender and receiver to be available at the same time, whereas asynchronous communication allows them to interact without being available at the same time. What is an idempotent? See, this synchronous and asynchronous communication is in the sense for microservices. So when synchronous is there, then that both are receiver and sender is available at the same time. But for asynchronous, they might not be available at the same time. What is the idempotent operation? Idempotent operation is one of that can be applied multiple times without changing the result beyond the initial application. How do you implement rate limiting in microservices? Rate limiting can be implemented using API gateways, client-side libraries, or server-side tools like Nginx or Envoy. So rate limiting in microservices can be implemented using API gateway. That means we can control the number of requests that is coming uh, to the API gateway. Okay, so we have configuration through which we can implement rate limiting. So next is, what is the 12th factor app methodology? The 12th factor app is methodology for building a software as a service application that use declarative formats for setup, automation, have a clean contract with underlying OS, and suitable for deployment on modern cloud platforms. So moving ahead, so we understood 12 factor app methodology. We have 12 different factors that we should be taken account so that we develop a resilient web application in microservices. So what is the canary deployment? This also I'm skipping right now. How do we implement fault tolerance in microservices? Already discussed. We will use circuit breaker like for retries, fallbacks, and bulkheads. What is a bulkhead? Bulkhead pattern isolates the elements of an application into pools so that if one fails, the other will continue to function. What is the role of Kubernetes in microservices? Kubernetes is an open source platform designed to automate deploying, scaling, and operating application container. It helps manage microservices in a containerized environment. So when it comes to scalability, when we need multiple instances of one application, one service, sorry, when we need multiple instances of service, when that we call as orchestration, in that scenario we use Kubernetes. What is a service mesh? Is dedicated infrastructure layer for handling service to service communication. So I will continue the rest of problems in the next part. Thank you for watching. Have a good day.